We will now see a lemma which lets us simplify the definition of control dependence. If we look at this figure, we see that V is control dependent on U, and W is also control dependent on U. But the interesting thing here is that V and all other vertices on this path are post-dominated by W. Okay, and what the lemma says is that if W post-dominates V, then that is equivalent to W post-dominating every vertex on this path. So how can we prove that? Well, it's easy. We can look at the right direction first. So we can assume that there is a vertex, or actually an edge from a vertex, which skips this one. And that means W does not post-dominate this vertex. Okay, so what happens then? Well, then there is a path from U to V and to exit, which skips W. In other words, that W does not post-dominate V, which was an assumption, so that edge cannot exist. Okay, and in the left direction, since V is on this path, I mean V is one of these, it follows directly. Therefore, we can simplify the definition of control dependence and make it very similar to the definition of dominance frontier. With this lemma, we can skip the requirement that W post-dominates every vertex on this path. It's sufficient that it post-dominates the first vertex. Okay, so, well, let's start let's start recalling dominance frontier. Okay, for a vertex U, V is in the dominance frontier of U if there is a predecessor of V such that U dominates V and U does not strictly dominate, U dominates P and U does not strictly dominate V. Okay, now with the lemma, we can say that V is control dependent on U if there is a successor to U, that means this one, for instance, and V post-dominates this successor and V does not strictly post-dominate U. Okay, so what we see here is that they are basically the same, except that they are in different graphs. This one is in the normal control flow graph and this one is in the reverse control flow graph. We can prove this, and if V is control dependent on U in the control flow graph, then it means that U belongs to the dominance frontier of V in the reverse control flow graph. Okay, and why is that true? Well, it follows directly from this lemma and the definition here. Since if V is control dependent on U, it means that it post-dominates a successor of U but does not strictly post-dominate U, which is exactly the same as U belonging to the dominance frontier of V in the reverse control flow graph. Let's look at an example. We can take this again. So what is it control dependent on? W is control dependent on itself and on these two nodes. Okay, and if we now look at the reverse control flow graph and see the dominance frontier of W, first of all, W is itself in its dominance frontier, since there is an edge back, and then V and U are also in the dominance frontier of W. This is pretty neat.